All right, so we are going to take a look at Rational Day 3 homework. So on number 1, it does say for problems 1 through 4, find each of the indicated graphical properties. If a function does not have a particular property, explain why it does not show your work. All right, so on number 1, we are going to ask to find the zeros of the function. So before we do that, I'm going to have you answer the questions that follow for number 1 for A, B, C, and D. All right, so for the zeros, we want to make sure that we are taking a look at the non-canceling factor in the numerator, and we set it equal to 0 and solve. For the y-intercept, we need to be able to find those constants. So what you're going to do is multiply out the constant. So you got the 4 and you got the 2, that gives you 8. And then the -4 and the +2, and that gives you -8. So as the y-intercept, you end up getting 0, -1. The vertical asymptote is going to be that non-canceling factor in the denominator. And so when you solve for x, you get 4, and then the coordinates of the whole. So remember that you want to be able to eliminate the canceling factors, and then going to identify, well, first you have to identify that the canceling factor is x equals -2. And then once you do that, you're going to plug it into what remains, and then you have the coordinates of the whole. All right, so now let's take a look at number 2, and then have you factor and then answer A, B, C, and D. All right, so here in factored form, hopefully you were able to factor that right. The 0 is going to be x is equal to 2. Again, we want to be able to identify the non-canceling factor in the numerator. The y-intercept, you could just look right over here, and you're looking at those coefficients, and then you end up getting the ordered pair 0, -1. Vertical asymptote is going to be x plus 2, which gives you x equals 2, and then the whole. So the whole is going to be at -3 because of the x plus 3 top and bottom. So once you remove the x plus 3, you plug it into what's left, and you end up getting -3/5. All right, so on number 3, go ahead and factor and then answer A, B, C, and D. Okay, there's the factored form, your zeros, your y-intercept. Again, you could just take a look at it with the -6 over -2. Put that in ordered pair. Vertical asymptotes. Notice that there's no canceling factor, so you have x equals 2 and x equals -1. Notice that there's no common factors top and bottom, so there's no wholes. All right, there's no factors that cancel out. So number 4, go ahead and factor and answer A, B, C, and D. Okay, here's our factored form. The zeros, remember to identify anything that's going to cancel out. We've got our x minus 2's that are going to cancel out. So you take those non-canceling factors, solve for x. The y-intercept, you've got your 2 over the -4. So you got 0, -1/2. Vertical asymptote, it's going to be at x equals -2. And then the wholes. Remember that the whole is going to occur at 2. Cancel that out, plug it into the simplified form, and you get the coordinates of the whole. All right, now let's take a look at 5. It says, in both factored and standard form, what is the equation of the rational function? Well, the first thing, it is easy for you to put things in factored form. So let's start with the denominator. Notice that the vertical asymptote is x equals -3. So in factored form, it's going to be x plus 3, and then you also have the whole at x is equal to -2. So let's make sure that we put that in factored form. And then what's going to happen is we need to find the x-intercept, which if you look at the x-intercept, looks like it is occurring right here at -1/2. And then you also have the y-intercept. So remember that the y-intercept is, if it's 1, we got to take into consideration that if we were to divide, if we multiply certain things out, we've got to reduce it to 1. And then you also need to pay attention to the horizontal asymptote. So let's take a look at that factor. So we get 2x plus 3, right? That's going to be negative 1.5. That's going to be that x-intercept. There's a whole at negative 2. And so if you were to just quickly check, if you notice, you're going to have what's left is 2 over 1, and that's going to help give you your horizontal asymptote. But at least right now, if these are your factors, this is the common factor, the x plus 2's, that'll give you your whole, and then you actually have your y-intercept. Okay, so that's the easiest way to figure out your equation. All right, so again, we want to make sure that you have your equation here, and then we have your whole, and then in order for there to be a whole, you have a constant or the same factor top and bottom, and then this other factor is your y-intercept, which is at negative 1/2. All right, now all you would need to do is to multiply that out, and that's what you would get. All right, so number 6, if you could answer the question, it says what factor is guaranteed to be in the denominator, and then justify your answer. Okay, so let's take a look. On number 6, since g of x has discontinuities at x is equal to negative 3, right, because that's your vertical asymptote, and then at negative 1, because there's a whole, x plus 3 and x plus 1 are factors of the denominator. All right, let's take a look at number 7. What factor is guaranteed to be both in the numerator and the denominator? Okay. All right, in order for there to be a whole, there has to be the same factor top and bottom. So since x equals negative 1 is a whole in the graph, then x plus 1 is a factor in both the numerator and the denominator. Number 8, what factor is guaranteed to be in the denominator of the equation but not in the numerator? Make sure you justify your answer. Okay, so to make sure that it's not in the numerator, then that's going to end up being our vertical asymptote. So since x equals negative 3 is a vertical asymptote, then x plus 3 is a factor in the denominator that is not in the numerator. All right, it says if g of 3 over 2 is equal to 0, then what is the equation of g of x in both factored form and standard form? So they're actually identifying number 9 as the 0. So let's see if you can try that. All right, so we should know that in the denominator we have x plus 3 and x plus 1. We also know that x plus 1 is in the numerator because of the whole. And then now we just need to establish the 3 halves, which is given by now the 2x minus 3. All right, what are the domain and range? Oh, sorry, wait, let me go back to number 9. We also want it in standard form. So you just multiply that out, and then you would have g of x in standard form. Okay, number 10, see if you can identify the domain and the range. Okay, so here we have the domain is basically all real numbers except negative 3 and negative 1. And then we have the range, which goes from negative infinity to negative 2.5. That 2.5, the negative 2.5 is the y location of the whole. And then it goes to 2, which is that horizontal asymptote, and then goes on to infinity.